Hello everyone! In this video, we will solve a one-way ANOVA problem step by step. Many people claim that graphic design, fine arts, and biology students score the same in programming. However, I believe that at least one group performs differently. To test this claim, 5 samples were collected from each group, and the data is shown in the table. Step 1. State the hypotheses. First, we define the null and alternative hypotheses. Null hypothesis, H. The mean programming scores of all 3 groups are equal. Alternative hypothesis, H. At least one group has a different mean score. Not equal to. Step 2. Identify the test statistic. Since we are comparing the means of more than 2 independent groups, we use a one-way ANOVA test. Step 3. Level of significance. The level of significance is given as alpha equals 0.05. Step 4. Decision rule. We determine the critical F value using the F distribution table. Number of groups, K equals 3. Total sample size, N equals 15. Degrees of freedom. Between groups, K1 is equal to 2. Within groups, NK equals 12. From the F table, F dot 212 equals 6.93. Air decision rule. Reject H if F calculated greater than 6.93. Do not reject H if F calculated less than or equal to 6.93. Step 5. Calculate the test statistic. Using the data from the table, we calculate mean for each group, sum of squares between groups, SSB, sum of squares within groups, SSW, mean square between groups, MSB, mean square within groups, MSW. The F statistic is calculated using F equals \frac MSB at MSW. To verify the calculation, we can also use an online ANOVA calculator such as mathcracker.com. Step 6. Conclusion. After comparing the calculated F value with the critical F value, if F calculated is greater than 6.93, we reject the null hypothesis. This means there is enough evidence to conclude that not all 3 population means are equal. Therefore, at least one group performs differently in programming scores. Step 7. Post hoc test. A one-way ANOVA only tells us that a difference exists, but it does not tell us which groups are different, because the result is statistically significant. A post hoc test such as Tukey's test is needed to identify where the differences come from. That's how we solve a one-way ANOVA problem step by step. Thank you for watching.